Hello everyone, welcome back to Aero Hub and welcome to the series of lectures in Gate Concept. And in the previous lecture we discussed about equation of motion and we derived that for a level and accelerated flight, lift is equal to weight as well as the thrust is equal to drag. And in this lecture we will discuss one of the important topic, that is thrust required for level and an accelerated flight. And we will use the same equation of motion. You can see equation number 1, thrust is equal to drag and this is equal to Q infinity. Q infinity is nothing but dynamic pressure. It is equal to half rho, that's density, V infinity square. Okay, this is the equation for dynamic pressure. Okay, Q infinity S CD. S is the wing area, CD is the coefficient of drag, lift is equal to weight, that is equal to Q infinity SCL, where S is the wing area, CL is the coefficient of lift. Okay, now I am dividing equation number 1 with respect to equation number 2. So I will be getting thrust upon weight is equal to CD by CL. Okay, Q infinity S will be cancelling out from both equation 1 and equation 2. So finally I will be getting equation number 3, T by W, that is nothing but thrust to weight ratio is equal to CD by CL. Okay, and from this equation number 3 I can write an equation, thrust required is equal to weight upon CL by CD, and I can write this equation as weight upon L by D. Okay, this is the actual equation for the thrust required. Equation number 4 is the actual equation for the thrust required. It's a famous equation. I think you all are aware about this equation. TR, which is nothing but thrust required, is equal to weight divided by L by D ratio. Okay, what is this L by D? It's nothing but an aerodynamic efficiency. Okay, L by D is nothing but the measure of aerodynamic efficiency. And from equation number 4 you can see that when L by D is getting increased, the thrust required will be minimum. When L by D is maximum, the thrust required should be minimum. Okay, this result you have to just understand. And we have a famous curve between thrust required and the velocity, and this is the shape of the curve. Okay, and we have to understand lot of things from this curve. This curve is for a particular altitude, and also you have to understand for an airplane, for a given airplane at a particular altitude at a different velocity, the thrust required will be various. Okay, for a given at different velocity, the thrust required will be varying, and this is that curve. Okay, and you can see that we have 2 points. I am taking 2 point A and B. One is at at point A the velocity is higher, and at point B the velocity is lower. Okay, so from left to right we have increasing velocity. Okay, this is one of the important thing you have to understand. From for this curve from left to right we have increasing velocity, and you have to understand lift is equal to Q infinity SCL. Okay, Q infinity is nothing but half rho V square. Okay, at point A we have certain amount of lift. Okay, at point A we have certain amount of lift, and at point A the velocity is higher. Therefore the lift is mainly derived from dynamic pressure. And at point A, when the aircraft is flying, the value of coefficient of lift as well as the angle of attack will be very less. Okay, it is very important. At point A, when we are operating, the value of coefficient of lift as well as the angle of attack is very less, since the value of dynamic pressure is very high. Okay, and one more important thing, at this point we are having higher velocity as well as higher thrust. That means we will be having more amount of drag. Okay, at this point B, you can see here at this point B the velocity will be very less when compared to point A. Therefore, dynamic pressure will be decreasing. Okay, that is the reason why the drag and thrust required is decreasing initially. Okay, the drag and thrust required will be decreasing. Okay, since the dynamic pressure is decreasing, to support the weight of the aircraft, we have to increase the value of angle of attack as well as the coefficient of lift. Very important, to support the weight of aircraft at this point of operation, we have to increase the value of CL as well as the value of angle of attack. Very important. And you also have to remember, drag is equal to CD naught plus CDI. CD naught is the zero lift drag, CDI is the lift induced drag, and lift induced drag is equal to CL square by pi EAR. Okay, pi E is nothing but the efficiency factor, AR is the aspect ratio, and we have a factor of CL here. Okay, when the aircraft is operating at this region, we will be having more CL, and since drag is CDI, we have CL square term. Okay, since we have a CL square term, the drag will be increasing after a certain point. Okay, this is why, since the value of Q infinity is decreasing, we have a sudden decrease in the thrust curve, thrust required, and since the CL value is increasing, the value of drag as well as the thrust is increasing after a certain point. Okay, and at this point, this is the minimum thrust required. We have an important result. The value of CD naught is equal to CDI, that is zero lift drag is equal to lift induced drag. And one more important case, at this point the angle of attack is very less, at this point the angle of attack is very high, and if I am going from right to left of this curve, we have an increasing angle of attack, increasing alpha. Okay, if you are going from left to right, we have increasing V infinity. If you are going from right to left, we have an increasing angle of attack. Now we will see the important tips for gate examination from thrust required topic. And I have mentioned earlier, at minimum thrust required, the value of zero lift to drag will be equal to the lift induced drag, that is CD naught is equal to CDI, and CDI is nothing but CL square by pi into E into AR, where E is nothing but efficiency factor and AR is the aspect ratio. Okay, and I can write CD naught is equal to K CL square, where K is equal to 1 by pi E into AR. Okay, and from this equation I can write CL is equal to root of CD naught by K. This equation is very important. This is a very VVIP. Okay, very important person. And one more important case, we have CD is equal to CD naught plus KCL square. Okay, and this is nothing but CDI. Okay, instead of CDI I am substituting KCL square, and CD for minimum drag, that is for minimum thrust required, is equal to CD naught plus K into CL square. Instead of CL square, I can substitute as CD naught by K. Therefore, CDMD, that is CD of minimum drag, is equal to 2 times CD naught. Similarly, the velocity at minimum drag is equal to root of 2 times W by S divided by rho into CL. Instead of CL, I am substituting as root of CD naught by K. Okay, about this lecture. Thank you for listening. Take care.